The idea today is not too much to speak about the theory about the stratigraphic relations, stratigraphic reconstruction, and so on, because this is something I was trying to mention already yesterday. But the idea was to focus mostly on the practical activity we had yesterday, which was in some way left not in the middle, but in this part of the problem, so to say, was not discussed because we didn't have time. And actually, I am indebted with some questions we had yesterday. Since not all of you participated to the Mars activity, I hope I will be able to go slow, which is actually not my best strength. So if something is not clear, please do not hesitate to tell me something. Okay, some theory we have to do. Stratigraphy, we told already yesterday, it's clear, I think, to everybody, is the tool to order rocks, or maybe we should call them units, since we are speaking of planetary setting. We do not have really idea of the lithological content. By the way, everything, unit, structure, whatever, and we want to link this feature. And we do this by visualizing and understanding, first of all, the visualizing the lateral and vertical relations among these units and all the structure. And also we want to focus on the missing time, which is quite subtle because just because it's missing, so it's difficult to detect. Oh, sorry. Okay, now the idea of this of the stratigraphic reconstruction is not only to understand the geological evolution of our study area, specific study area, which of course is the first step, but it's also to include this evolution, the specific evolution I'm working on in the framework of the whole planet geological history. This is, of course, something to perspective, but it's the base to infer the global changes and their controls through time. So it's very important also at the planetary level, not only at the local level. We start from geological map. We should always start from geological map, because geological map is the base to understand whatever area we are working on whatever planet. We define units. Yesterday we were mostly focusing on distinguishing units and structure. And of course, when we map these units and structure, we describe their geographical distribution. Stratigraphical informations are some way already there, and Matteo just gave a beautiful presentation on geological section, how to reconstruct there, and how, I mean, the information are there. We need to, in somewhere, extract this information from the geological through geological section, as you saw, which focus mostly on the geometrical relations with units, and through stratigraphic schemes, which all means respect to time in different ways. Units can be superposed, can be quavered, and we can have missing time. These two products, of course, together with the legend, yesterday we were focusing a little bit on the description of the unit at all scale. That will be part of the legend. It's very important. But this geological section, the scheme, should always be associated to the geological map. This is important. Maybe you can have different kind of representation, different kind of sketches. Maybe you can use sketches and not the geological sketches, the geological section, sorry. You can use different stratigraphic schemes, but in any case, this information should be present. And how can we do this? No? How can we practically derive stratigraphic information from our map? Also from our sections, our outcrops. First of all, we need to focus on the observation of the contacts between the different units and the different structures that we have in our area. Ideally, starting from what yesterday I called reference areas, maybe it's a little bit improper as a term. It's the correspondent of the stratotype. Yesterday we were working on Arab cows and chaotic terrain, as the name clearly suggested. We have these chaotic terrains, we have outflow channel here. The area is huge. We didn't have the chance to prepare reference section for all of the units which are developed here. We just selected two areas, so I will focus also on other areas to try to infer the evolution of the whole area. Let's start from here. Here we have the plateau. This is a perspective view. All the perspective view I'm showing, I will show during this sort of lecture are have a vertical exaggeration of 1.5, so they are just slightly vertically exaggerated to not to lose too much the reality, so to say, but to emphasize, you know, the contacts and the stuff. This is the plateau. These are mesas, and the mesa form because of this fragmentation. Actually, this is very nice. We have one crater, this is super cool, which is post-dated, like these fractures, which can hit. While, for example, this crater is younger than the formation of the chaotic terrain, because this fragmentation leads to the formation of the chaotic terrain. Basically, the idea is that we had the plateau, then the plateau was fragmented, which means what? Means that the material forming the plateau and the material forming these mesas and also the knobs, we will see them later, is the same. But there was a post-depositional process, which is this fragmentation, these fractures, that led to the formation of two different geological units. So, a plateau fragmented to originate mesas and knobs. We have already a succession of events in our area. Then let's move to the reference area B, this one. This is just a screenshot, very quick and dirty, with a topographic section, which is reported here, just to give you an idea of the scale, especially for the people who were not yesterday at the practical activity. We have here some, let's start from the light tone, this light tone deposit. We will see that they are layered. These are the knobs. Here, these huge, of course, they are big guys. And this is a unit capping the layered deposits. In fact, it's called a cap unit. I should say that I am broadly speaking of units that might also be subdivided in even more units, but I want to be very simple. I hope not superficial. If you go here and make use of the high-rise set, we can see that the layer deposits are actually layered. We can see that they are maybe reworked by this Aeolian probably landforms. They are covered by this cap unit, which is the cap unit is in turn reworked by these aeolian deposits, which appear to rework the sediments of the cap unit here, but also these aeolian bed forms are present on top of the layer deposits in different places. This is a very simple, the contact between the aeolian bed forms and the layer deposits and the cap unit is a very simple example of unconformable layer. You have this unit, these aeolian bed forms, which erode the cap unit and deposited on top of the cap unit and are transported and deposited on top of the cap unit and on top of the layer deposit. So it means that there is time between the formation of the layer deposit, the cap unit, the aeolian bed form. I will speak about the contact between the layer deposits and the cap unit later on. So this is a very simple stratigraphic relations. Now, if we move, sorry, this was too fast. If we move in another, okay, it was, I think you have the chance to see, to a little bit a larger area, okay, we described the unit in detail. Now let's like zoom out now to see in a better way the geometry of these units. We see that the layer deposits with a cap unit on the top. We see the knobs. I must confess you that before this lecture, I told myself to stop a few minutes to let you think, especially the non-Mars people, the people who didn't attend yesterday, to this to the practical activity to think about, but I'm not able to stop. So if you will not understand something, just please ask. We have the layer deposit, the cap unit, and you see here these two units. It's like they are going against the knobs. These are the knobs. No, yeah, it's like they are moving towards embaying the knobs and the aeolian bed forms on top. I hope you agree with this. Maybe there is also a perspective view later, which is more clear, but we have the layer deposit, the cap unit, which embed the knobs of the chaotic terrain. Which means, okay, this is the perspective view that show you the same thing. We have these deposits which sometimes cover the knobs, sometimes they just go against them with a stratigraphic fascia, so to say, which is called on-lap. So we have these beds which goes against this inclined surface, which is actually the bounding surface of the knobs. And sorry, it's to do like this. So the layer deposits and the cap unit, again, please have patience. I will speak about the transition between these two units later. They overlap the chaotic terrains. Just to be more clear about this and hoping to convince you, if somebody is not convinced yet about this, we can move to see the very same relations in another area here. Here we have the layer deposits, this white tone stuff here, the mesa of the chaotic terrain, and you see it like this. These terrains are moving, and actually here they are nicely filling the space between the fractured space between the mesas, and they are able actually to infill up to a certain level, because you see here there is nothing. So that would be a nice question for the science later to understand whether these layer deposits were never able to reach these places, or they were able to reach it and then later they were eroded. This is something which is a step forward in the knowledge of the area. This is the science part. But now we are looking at the stratigraphic relations between the units. So the layer deposits are, I think it's very clear here, they're overlapping against the mesas. which means they are postdating the mesa. Sometimes they are even drawing. Some part of the deposits are almost disappearing below the layer deposit, which are, this is, I apologize, the sketch is awful, but these are the knobs or the mesas, is the same. These are the layer deposits which overlap. So the layers are going against the mesas in this way. This implies that we are infilling the bases. Actually, not opposite. The layer deposits are infilling the bases. Okay, this is just very roughly done, very, very much not to scale, but just to give you an idea. Okay, I let this part, the relations between the layer deposit and the cap rock, cap unit, sorry, still there. But first we have to look at the relation between this unit with the outflow channel. Outflow channel is a pretty important feature here because it's actually we do not have the entire, we have just the beginning, the source area for the outflow, the big outflow channel. If we move here, we can see a lot of stuff. This is the channel. This is the area which was subjected to erosion by the water, which were pushing and cutting. They were cutting this their way outside of the chaos. So these are erosional features. These are somebody yesterday called them. Let me premise that if I'm saying something, it is not intended to be a criticism towards the job you did yesterday, which was excellent. Just to focus on some points. These are erosional deposits, so there are no fluvial deposits. Then we might also argue that fluvial deposits and outflow are different processes. Outflow channels are catastrophic processes, so it's a little bit different stuff, but still, these are erosional processes because the water wanted to cut their way to go out of the crater, and you see that they are not just here. The erosion related to this water is pretty widespread. You can see here it's pretty diffuse. And here we can make two considerations. Let's start with the one we did also earlier. So also, we have here some layer deposits which are mostly covered by the cap unit, but you can still see some hints of this layer deposits somewhere, even here. And these layer deposits covered by the cap unit are overlapping with the knobs. Here we have the knobs, but actually they are overlapping also these erosional features related to the outflow channel formation. This is too early, sorry. And okay, we will go back to this in a second. I wanted also to focus on another point. Because yesterday somebody was asking me something about the relation between mesas and knobs. Why we have mesas? Why we have knobs? Why we have knobs of different dimensions? Actually, something was pretty addressed yesterday by the beautiful talk Erika gave yesterday afternoon. But I can add something from this image because this image is very cute. Here we have knobs, and here we have a knob, some knobs which look like just formed from a mesa. It's like a sort of transition, like here. What I am trying to say that knobs originate from further erosion and fragmentation of the mesa. So same process, different landforms. which explain why all of you mapped, I guess all of you mapped this as different units. Some of you mapped also the knobs in different ways depending on their shape and on their density. And this is interesting because here there is something else which come out. The knobs here are extremely fragmented and very small here, right in association with this outflow related feature. So it means that also the fluvial related, outflow related structures were active in disrupting these materials, which are these knobs, which are disrupted in this way only in correspondence of this part of the outflow channel. Here again, the overlap of the layer deposit and the cap unit against the knobs, but also against the, let's say, landforms shaped by the outflow channel. I know I'm putting a lot of things together, but we will try to put order in a while. So again, layer deposits on like the chaotic terrains and the terrain shaped by the outflow. Now, finally, let's focus on the transition between the layer deposits and the cap unit, which I was postponing a lot. Let's go to reference area A here. Again, a very quick and dirty screenshot from with this topographic profile, which helps you to have an idea of the scale. Some of you have even the project, so they can play with this. But in any case, you have this cap on top of the layer deposit. I will speak about the interpretation of this in 1 second. And you see that you have layer deposits here. You have a cap unit here, cap unit here. I'm switching from the image to the section just to let you visualize, so to say, that the cap unit is present at different elevations. And this is something that some of you were nicely addressing during their mapping project. This is the perspective view, which probably is more effective to explain this thing. And maybe it's the right place to point out that sometimes the cap unit looks different because, for example, here, are these layered unit or cap unit? Well, okay. You can see if you use your high resolution data set, you can see the layers here, but they are a little bit covered. So yes, there is a little bit of capping, a little bit, but not so much. Here there is much more capping because the layers are covered by a much thicker deposit. Here you have something in between. Some of you were mapping all the cap units which are present at different elevation in different colors, also because it is true, cap units have sometimes different look, so to say. And this makes sense. This is not wrong at all. It's a good representation because actually this unit, you cannot say it's the same as this unit or this unit. They are actually a little bit different. But conceptually speaking, depositionally speaking, they represent the same thing. Just different thicknesses of the same thing. This means that the transition between the layer deposits and the cap unit define an irregular surface. We have an irregular surface, and then the transition between layer deposits and the cap unit. I don't know if this image, this is an iris image, maybe here it's too close, but again, just to give an idea of this, we have the transition between layer deposits and cap unit. It's always reworked by wind, and this is why one of the reasons of this different level of erosion of the cap unit, because wind is acting in different way depending on the position of the unit itself. But again, this contact occur at different location, at different elevation, sorry. In other words, this is a disconformal, which can be explained by an erosion which precedes the deposition of the cap unit and cut some of the layer deposits. This erosion might occur by wind or by water. This is something that this is a further step. Again, this is science. So this is something that should be addressed later. But what we can see is that we have erosion. Again, this is just a sketch. And later, the deposition of the cap unit, which of course occur at different elevation because the physiography which were present at the time of its deposition was irregular. I designed it in a very poor way, but I hope it gives the idea. What I didn't draw it properly is that the thickness of these deposits are very different. This one is a bit different, very different. So their texture becomes different because sometimes you almost see the layer deposits below. Okay, now it's time to try to bring it all back home and try to put everything in order, because I am pretty sure I did some confusion with all these relations and whatever. Stratigraphic sketches are done just for this reason. So from the oldest unit to the youngest, and again, I want to stress that many of these units, especially this one, can be further subdivided. I want it to be, again, very, very simple, but it's very proper to divide all this unit. And again, it's not wrong to map this unit, which looks different, which has a different texture in a different way. It's not wrong at all. I will come back to this later. So we have the plateau, we have the formation of the chaotic terrains with the fractures related, and the unfold channel and the grooves which shape the terrain. It's difficult to say what is the stratigraphic relation between these two units. I will come back to this later. Then we have the layer deposits, the cap unit, and the organ vectors. Now we want to express this, what we understood, this stratigraphic relation. And we go back when we were at the beginning, to express this stratigraphic relations, we need some stratigraphic sketches, which can be of two kinds. And it's not that one is good and one is wrong, one is better, one. They are complementary. This is a space diagram, which is actually somewhat similar to the geological section. You can use a geological section actually to, sorry, I don't know. My neuron will never be able to control this. Again, so the stratigraphic, the geological section might be just perfect. The one that the beautiful ones that they will just show would be just fantastic to express this. And this kind of representation focus on the geometric relations, but also on the geometry of the unit themselves. Because, for example, we just saw that the layer deposits do not have the same thickness anywhere. They appear to disappear. Sorry for they appear to disappear. They disappear in some part of the basin. And we do not know whether this is because of depositional reasons, so they were formed and deposited with such geometry, or because of post-depositional erosion. This is something that again should be addressed later by science, but still we need to describe this fact. So we can show, for example, that the unit has a lenticular shape. In this case, we have a unit which has an irregular shape, and we want to express this. Or this unit which is localized only in some places and then disappear. Then we have the space-time stratigraphic scheme. The space-time stratigraphic scheme loses the information of the geometry because, but gains the information about time. This side of the space-time diagram is indeed time. So we want to draw here the units which are, for example, the channel here. No, the channel is just in this area. So we have the space because the channel developed only in one specific portion of our study area. But we lose the fact that the thickness of this body is not regular because we have a higher thicknesses here and the lower thicknesses here. We lose this because we want to know the time in correspondence of which this channel was deposited. And this channel was deposited at the same time in all this area. But what we gain, especially, is the information about the missing time. For example, the time which was missed because of erosion, and the time which was missed because of non-deposition. This is very important. This is very important because we can distinguish among our study area between different phases of its geological history. Okay, this is I would say, very awful representation, a very awful space diagram of our chaos. It's extremely much not to scale, not even a representation, just a sketch, just to have an idea. We have the plateau fragmented in to form the chaotic terrains. The layered deposit, which overlap against the chaotic terrains. We have the outflow channel, which shape a part of the deposit. The layered terrain are overlapping against this outflow channel. Then we have the cap unit, which develop unconformably, or better, disconformably on top of the layered deposits. And then we have the other platform, which are basically actually everywhere, capping all the units. These are the geometrical relations, again, very superficial, very roughly, but just to give you an idea in the study. Then let's try to switch to a space-time diagram. So to include the units that we just saw, or the grouped unit, like we prefer to call them, units and structure in one space-time diagram. So to infer their relation with time. First of all, we have the plateau formation. The plateau was eroded, and there was some time missing before the fragmentation to form the chaotic terrain. Sorry, this is very rude, this kind of drawings, but just to give you an idea. Now, what we do not really know, we are not certain, is whether this formation of the chaotic terrain is coeval with the, I put here the grooves, because the grooves are eroding this terrain. So this terrain were formed here and deformed later by the chaotic terrains formation and by the groove formation. We do not know whether these things were coeval. this is something that science should address. It's true that the fact that the mounds appear, sorry, the knobs appear to be very deformed nearby the outflow channel area, so to say, this points toward this direction. But again, this is something that should be tested. Formation of the chaotic terrain, possibly coeval with the outflow channel formation. Then we have the layer deposits. The layer deposits developed on top on an unconformable surface. So we had some erosion here, layer deposits, erosion, sometimes missing, capiumi, erosion, sometimes missing, aeolian platforms. If you design it in your map, the capiumi in different colors, that's just perfectly fine. Just here you should divide this area that I draw in a very poor way in your different colors because they are coeval. Now, I wanted just to show you an example which I didn't have time to show yesterday, and it was just by chance that over one of those big mounds that Matteo and Riccardo were speaking about just a few minutes ago. This is First Glacier, of course, on Mars. This is First crater. This is Cotigo crater. This is the plateau. This is our unnamed crater. This is the geological map of the area, where we were focusing on what we call the equatorial layer deposit. These are sulfate-bearing deposits. I don't know if you remember yesterday, I was super quickly mentioning the presence of the sulfate-bearing deposit, which can be also inside craters. They are actually also inside the chaotic terrains we saw earlier, but they are very different in the, except for the fact to be rich in surface. We draw just to mention something, the sulfate-bearing deposits, we were focusing on the one inside the crater, but they are actually also present outside of the crater with different morphologies, different, even sedimentary structure, because here there are evidences of aeolian or cross-bending of aeolian origin that we do not have. This is the geological section. The base of this crater has been inferred using the Garden equations. So you see, right, that mound you were mentioning before, huge thickness, I guess here is 2,000, more than 2,000 kilometers, something really, really huge. We've thought, speaking of formation, that this might have been related to spring, an interplay between spring deposits and aeolian also reworking. Playa contribution probably was more important, probably, in our opinion, was more important outside of the crater, together with the aeolian contribution. Despite of, I mean, we do not care about the genetic origin of this deposit. The important is that is to express these deposits in geometrical ways, so we know that the thickness is very different from place to place, and in a space-time diagram. So these deposits are roughly here within the early experiment. Here we could tie our representation with some crater counting. Again, we try to guess that these deposits are in the different craters and outside of the craters. Just a few remarks very quickly. The stratigraphic frameworks are the base for further science investigations, are the key to move from landforms to landscape, they should precede any kind of scientific construction. And this should be done with geological section and stratigraphic dive should be expressed with geological section and stratigraphic diagrams, which should always be associated to the geological maps, in order to nicely, clearly represent the vertical and lateral contacts among the units. And now maybe the most important thing is to, yesterday we didn't have time to make this collage. Collage is the sort of mosaic of the different units mapped by some of you, and please do not be upset if your map is not there. I did this work just this morning, very, very quick and dirty. But I must say that the job you did was very nice. Also, of course, they are not georeferenced, just done by hand. Of course, we didn't agree on the symbology before, because the idea was not to spoil the unit, because if you would have told me, okay, you use this color for this, your color for this, we would have spoiled the units. We didn't want to do that. And of course, the detail of the representation are different from map to map. In case of collaborative mapping, it's very important that you agree very carefully before on the scale of work, the units to map, and of course on the symbology. But this is of course not. It was of course not an issue yesterday. So thank you for the work you did. Thank you, and I hope I'm not too late.